Imagine everything around you vibrating. Every object, every particle, every bit of matter in the universe is in constant motion. Not just your phone or a guitar string, but everything. The vibrations are subtle, often imperceptible, but they are there, creating a symphony of motion. From the smallest atom to the largest star, the universe thrums with energy. This energy is the heartbeat of existence, a continuous dance of particles and waves. This isn't just a whimsical idea. It's a fundamental concept in physics. Scientists have long studied these vibrations to understand the nature of reality. The universe, at its core, is a sea of vibrating energy. These waves of energy are the building blocks of everything we see and experience. These vibrations, or waves, are not like the sound waves we hear. They are far more fundamental, influencing the very structure of the cosmos. They are ripples in space-time, the very fabric of the universe. These ripples carry information about the forces and events that shape our reality. To understand this, let's explore what space-time is and how it behaves. Space-time is a four-dimensional construct that combines the three dimensions of space with the dimension of time. We can visualize space-time as a vast, flexible sheet. This sheet can be bent and stretched by the presence of mass and energy. This sheet is not static. It can bend, stretch, and ripple. These distortions are caused by massive objects like stars and planets, which warp the space-time around them. These ripples are the waves we're talking about. They travel through the universe, carrying with them the echoes of cosmic events, like the collision of black holes or the explosion of supernovae. Space and time, once thought to be separate and absolute, are actually interwoven into a single entity, space-time. This concept, a cornerstone of Einstein's theory of relativity, revolutionized our understanding of the universe. Imagine space-time as a fabric stretched out, much like a trampoline. This fabric is not rigid, it responds to the presence of mass and energy. Massive objects, like stars and planets, create curves in space-time, much like a bowling ball would create a dip in the trampoline. This curvature is what we perceive as gravity. Now, imagine this space-time fabric not just bending, but also vibrating. These vibrations, or space-time waves, are thought to be fundamental to the universe's existence. One intriguing theory proposes that the universe itself is shaped like a torus, or donut shape, and vibrates in specific ways. This torus universe model offers a unique perspective on the universe's structure and evolution. Just as the frequency of a sound wave determines its pitch, the frequency of space-time vibrations could determine the properties of everything in the universe. These vibrations might dictate the formation of galaxies, the behavior of particles, and even the very laws of physics themselves. Imagine a universe where different frequencies create different realities. Higher frequencies might manifest as denser matter, while lower frequencies could give rise to more ethereal phenomena. We, as humans, would exist within a specific range of these frequencies, attuned to the reality we perceive. Section 5. Ripples in the fabric. Gravity's influence. Gravity is one of the most fundamental forces in the universe, shaping the very fabric of our reality. But what exactly is gravity, and how does it influence the cosmos around us? The concept of space-time waves also provides a new way to understand gravity. These waves are disturbances in the fabric of space-time itself, caused by the acceleration of massive objects. Imagine space-time as a vast, flexible grid that can be stretched and compressed. Instead of viewing gravity as a force acting at a distance, we can see it as a consequence of these ripples in space-time. When a massive object like a planet or a star exists, it distorts the space-time around it, creating what we perceive as gravity. Earth, for example, creates its own gravity well in the fabric of space-time. This well is a region where space-time is curved inward, pulling objects towards the center of the Earth. This is why we stay grounded and why objects fall when dropped. When an object moves, it creates ripples in space-time, much like a boat moving through water. These ripples are known as gravitational waves, and they carry information about the object's mass, speed, and direction of movement. These ripples, or gravitational waves, propagate outward at the speed of light, carrying information about the object's mass and motion. They travel vast distances across the universe, allowing us to detect events happening millions of light years away. The more massive the object, the larger the ripples it creates. For instance, when two black holes collide, they generate enormous gravitational waves that can be detected by instruments on Earth. These waves provide us with a new way to observe and understand the universe. Section 6. The Symphony of Matter. In this chapter, we delve into the profound concept that the universe is not just a collection of isolated objects, but a harmonious symphony of vibrations. If the universe is indeed a symphony of vibrations, then matter itself can be seen as a manifestation of these vibrations. Every particle, every atom, is a note in this grand cosmic orchestra, playing its part in the universal melody. Particles, the building blocks of matter, may be nothing more than concentrated knots or patterns within this vibrating space-time fabric. These knots are not random, but are formed by the intricate dance of vibrations that permeate the universe. Imagine the pond again, this time with ripples spreading out from the center. Each ripple represents a wave of energy, moving through the medium of water, just as vibrations move through the fabric of space-time. Where the ripples intersect, there is more energy. These intersections are akin to the points in space-time where particles form, where the energy is concentrated enough to create matter. This is like how particles might form in space-time. The energy from intersecting vibrations creates the conditions necessary for particles to come into existence, much like the ripples on a pond. These particles are not static. They constantly vibrate, interact, and contribute to the overall cosmic symphony. Their interactions are the notes and chords that make up the music of the universe, a dynamic and ever-changing composition. Their properties, such as mass and charge, would then be determined by the specific frequencies and patterns of these vibrations. Just as different musical notes have different frequencies, so too do particles have unique properties based on their vibrational patterns. This perspective blurs the line between empty space and matter, suggesting that everything is interconnected through this dynamic, vibrating medium. The universe is not a void filled with isolated objects, but a continuous, interconnected web of vibrations, where every particle and wave is part of the same cosmic symphony. As we expand our understanding of this symphony, we begin to see the universe in a new light. The galaxies, stars, and planets are not just distant objects, but integral parts of this grand, vibrating tapestry. And we, as conscious beings, are not separate from this symphony. Our very existence is a testament to the intricate and beautiful dance of vibrations that make up the universe. We are, in essence, a part of the music, resonating with the same frequencies that shape the cosmos. So, as we gaze up at the stars, let us remember that we are not just observers of this cosmic symphony, but active participants in its eternal melody. The Symphony of Matter is not just a scientific concept, but a poetic reminder of our place in the universe. Section 7. A Universe of Doughnuts. The idea of the universe as a vibrating torus, while still speculative, offers a captivating solution to some cosmological puzzles. A torus, being a closed shape, could explain the finite yet unbounded nature of the universe. Just as an ant walking on a donut can travel in any direction without encountering an edge, so too could we theoretically traverse a torus-shaped universe infinitely. Section 8. Resonating with reality. If the universe operates on the principle of vibrations, then resonance, the phenomenon of amplified vibrations at specific frequencies, could play a crucial role in shaping our reality. Objects and systems that vibrate at similar frequencies tend to interact more strongly, influencing each other's behavior. This concept of cosmic resonance could explain the formation of galaxies, the stability of solar systems, and even the emergence of life itself. Perhaps life arose on Earth because our planet resonated at frequencies conducive to the complex chemistry required for life to flourish. Section 9. The search for cosmic harmonies. Scientists are actively searching for evidence of these space-time waves, using sophisticated instruments like the Laser Interferometer Gravitational Wave Observatory, or LIGO. By detecting and analyzing these cosmic ripples, we can gain a deeper understanding of the universe's most energetic events, such as black hole collisions and the Big Bang itself. These observations could confirm or refute the Torus universe model and provide invaluable insights into the fundamental nature of gravity and the universe's origins. Section 10. A new perspective on our place in the cosmos. The concept of a universe built on vibrations offers a profound shift in perspective. It suggests that we are not isolated entities, but rather integral parts of a vast, interconnected cosmic symphony. Every atom in our bodies, every thought we think, is a manifestation of this underlying vibratory reality. This view fosters a sense of wonder and interconnectedness, reminding us that we are not separate from the universe, but rather an intimate part of its grand cosmic dance. As we continue to explore the universe's mysteries, the music of reality awaits our discovery.